M should always be odd. Okay. Now I don't know about how exams are given in India. At least here when I give my tests, I would never ask a student an exam question called, give me the definition of a B tree with all the 5 rules. All the 5 rules. I would never do that. Because no one needs to remember all the rules. You just need to understand some concepts, right? If some professor gives such types of questions, generally, at least here I would say, hey, they don't know what they are doing. I always tell them, remember what Einstein said. What you can find in a book, there's no need to memorize. Okay. So here is an example of a B tree. Okay. Listen carefully because you'll be doing the exercise in 2 minutes. It's all going to be hands-on learning, okay? From now onwards. Rather more hands-on learning. So here is a B tree of order 5. 5 means it can have up to 5 children, right? Okay, and it has 26 items here. Okay. Now how this is constructed is a different story. Okay. But you can see there are 5 and all the leaves are at the same level. What is the depth of this tree? 2, right? 1, 2, yeah. 1, 2, yeah. So that is the depth of the tree, and then you get a tree looks like that. Remember, this one, they both are visual. They may not be the same to the eye. They are all 2D. Okay? For convenience, they draw it like that. Okay? Let me go to the next slide. Right? Now how do we construct the tree? Okay? Here is where the fun begins. So we want to construct it based on the values that are coming here, 1, 25, and so on. Now when you construct a tree, remember we need to know what is the order of the B tree, right? Here the order is 5. Okay. So now here is the very first node. Should be there in the root node m-1 keys. Remember, it's always 1 less than the order. So when the node, they're all sorted. So when you get this 1, 12, 8 and 2, they are cleanly put in 1, 2, 8 and 12 in a sorted order. Everyone understand so far? Step number 1, pretty easy, right? You need to know the order. Since you know the order minus 1 is where the keys would be, the indexes, okay? And then they are always sorted. Okay, so you get the 4, 1, 2, 8 and 12. Now you cannot put the 5th item in the root. What is the 5th item coming? 25. Okay? Now you cannot put it in the root. Why? It is violating a condition. What was that condition that it's violating? If you go back, you can see it. See that? Leaf node contains no more than m-1 keys, right? When there is only one node, root and leaf are the same, right? So it cannot contain more than m-1. It's going to violate that. So since it's going to violate that, you cannot put that in the leaf. Okay? Faculty members later on, when they are doing the exercises, you can help them with that. A little bit guidance would be helpful. So what do you do when 25 comes? You have to make a decision. So this is where you start building the tree. Fair enough? Simple? Too easy for you? Or is it too hard? Okay. Now, so when you do that, How do you make a new root? You pick the middle key. So when you put 1, 2, 8, 12 and 25 in order, the middle key is 12, 2, 8, 1, 25. What is the middle key? Put it in the chat. Middle key is 8. Okay? So you take 8 there. Now you start building the tree. Anything less than 8 goes to the left, anything greater than 8 goes to the right. Okay, let me pause here for a second. Is there anyone who does not understand what we have done so far? Questions, comments? Okay, everyone is listening intently. I can see the pictures there. Okay? One more time with feeling. I'll explain it one more time with feeling. Okay? Because we are going to be doing the exercise now. So when we have an empty B tree and some keys are coming, values are coming, and the instructor or your exam question says construct a B tree of order 5. Okay? Show your answer. That's what they would say. So the first 4 items, you put them like that, and then they're always sorted. Okay, that is rule number 1 in tree. Now if you put the 5th item, it's going to violate, because when you say order of M, the number of keys in the leaf node should always be one less. By putting 5, it's going to violate. That means you now have to build a tree. You have to break that leaf node into 2 and then create a new root. And the way you create a new root is, you put them in that order 1, 2, 8, 12 and 20. You take the middle value, make that the root. Anything less than the middle goes to the left subtree, anything to the right of the middle goes to the right subtree. Okay? So far so good, right? Okay. Now we are adding 6, 14, 28. So where does 6 go? You compare 6 to 8. Remember, now you go back to your binary search principles, right? That's the beauty of binary search. Right? You are able to say whether I take the left branch or the right branch. So you go to the left. Still has room, right? It can go up to m-1, 4 values. So 6 can fit in there. 14 goes the other side. And then so does 28. Okay? Now you are adding 17. Okay? So when you are adding 17, the leaf node is getting overfilled. So again apply the same principle. What is the principle? In that 5 order, take the middle one, bump it up. So when you bump it up, where are you bumping it up? You're bumping it up to the root node with 8. And there is room there because it can go up to 4, remember? So you put 17 there and then make a left subtree, right subtree coming out of 17. Okay? Is there anyone who does not understand that? Here is your chance to raise your hand. That way I can explain it one more time. Okay? Okay, so far so good. If you understand 50% of it, when you do the exercise, now I make my students do a lot of in-class exercises. If I simply give you all the theory and say, okay, go do this as homework, 50% of the class would go watch a Mahesh Babu movie. They will not do this. Mahesh Babu is more interesting than data structures. Any day. I would take Samantha also any day over data structures. Okay. Kajal for that matter, right? Lot of great people now in the movies. So, okay. Are there people there who bunk classes to go watch movies, by the way? Or you don't want to admit it? Okay. Faculty members would kill me if I'm saying all of these things, right? When I was a student, when I didn't like... Okay, Jntuk V also completed. So let's pick one of them. Okay, Jntuk V, we'll try. Since Jntuk K got some chances before. Let's take JNTU for now. If I make JNTU presenter, let's see how creative you can be. Okay, I made you the presenter, JNTU. I'm not the presenter right now. JNTU has, okay, they are showing it on the board. You're showing it using your video camera there. Can you put it on the whiteboard or put it on a laptop and show it? Or how do we see that screen? A little bit challenging, right? Right? Email it to yourself, open it up from the laptop, bring it into your PowerPoint and show it. That's one way. Since you are all more tech savvy than I am, you can probably figure out a better way to, right? Let's give it a shot for a minute. Or you can take the whiteboard, you have control of the whiteboard here, you can write on it. Because I made you the presenter. Yeah, you are the presenter. You can even present it. Okay, you're putting something in the chat. Let me try to put it here, okay? Okay, and then I will try to draw it for you. Okay, I took the control back. Let me put a new whiteboard. And then you are saying 14 is the root. Okay, let me open that. Then 5, 9 to the left. So I should go 5 here, comma 9. I hope I'm doing it right. 24, 30. Okay. What else? Only that many numbers I gave, or did I give anything more? Let me check how many numbers I gave. I don't even know. Oh, we have more numbers, right? Yeah, we have plenty of numbers. So 1, 3, 4 to the left of 5. Okay, I'll put here 1, 3, 4 to the left of 5. Okay, then 1, 3, 4 to the left of 5, and then anything to the right of 9. 7 and 8 to the right of 5. 7 and 8 to the right of 5. Okay, I screwed up in terms of putting it in. 7, 8 to the right of 5. Okay, that's 9 is greater than that. 11 and 13 to the right of 9. Okay, I'll say this one is 11, 13. Okay, so on the left subtree then you have 14, 5, 9, 1, 3, 4, 7, 8, 11, 13. Okay, excellent. Let me put the I'm just duplicating the same value here for convenience. Okay, okay, continue. So what do you get to the left of 24 and right of 24 and left of 35 and right of 35? Now JNTU Kakinada, your work is looking the same as JNTU, or do you find any discrepancy? If you find any discrepancy, put it in the chat. and 23. Okay, to the left of 24. Okay, sounds good. Whiteboard, the whiteboard that comes with WebEx is a little bit kludgy, so if my numbers are not aligned, I apologize. I cannot do anything with this whiteboard. So 24 and 35 to the right of 14. Yeah, 24 and 35 are right of 14. You're right. We already have it here. See this one on the whiteboard? You're right. 19 and 23 are left of 24, correct? Give me a second, I have to close my door. Okay, I'm back. 45 and 56 are to the right of 35. 45 and 56. Excellent. We almost covered all the numbers, right? So let us stop right there because that's a great illustration. JNTV, I did all the groups were, how many groups were able to finish it in JNTV? I see a lot of young kids in Chaitanya who are enthusiastically looking at the board. I just lost your video. Did Jntuk get it? I think Jntuk also started off telling me. Okay, excellent. Anyway, if I ask, did you get it? Every college would say they got it, right? Because they want to make sure their college looks good, right? Why would they say they didn't get it? Okay, but you can see how I'm doing this. Okay, so let's exercise very soon, believe me. This class is all exercise driven where you learn by doing it. Okay. That is insertion. Okay? How do you remove it? Right? One is insertion. Remember from databases it's always about insert, delete and update, right? So remove from a leaf. Okay? So there are three scenarios where deleting something. The three one deleting something. The three is one. I think in the leaf if you the leaf. Again, theory is one thing, doing it another thing, right? And then obviously when you're doing either of those things, and if any of the conditions, like if it lead to a leaf node containing less than a minimum number of keys, then we have to look at their siblings, right? Siblings in question, right? And then do the manipulation, like apply rule number 3 and rule number 4. Okay, so whenever you're doing these things, remember, go back to the fundamentals of B trees, right? If you remember those rules of B tree in terms of when it's becomes easy. to remove it. Okay. Chaitanya said yes, that's good. That means they got it. Okay. So here is an example, okay, of deletion of this. So we have this one. So you want to delete, what are we deleting here? 12, 29, 52. Since there are enough keys in the node, just delete it. What are we deleting here, by the way? I don't even know what we are deleting here. Node, just delete. This is a 5-way tree. So we want to delete some value, and it's saying there are enough keys in the node, just delete it, because enough keys meaning they should meet the criteria of m-1, right? As long as that criteria is met, you can delete it. Okay? That's so we are deleting 56. That's what it did here. This is a non-leaf. Okay? If you are deleting 56, 56 is not here. It goes up, so you can see the flow. Right? Because you have to make sure all the rules of the B tree are in compliance when you are trying to delete a node. Okay? So as you can see here, it shows the example to delete. If you delete it, then you have too few keys. So when you have too few keys, then you have to join those things together, build the tree up again. Right? You cannot violate the rules of the B trees. Okay? Okay, so bunch of variations like that. Again, by just telling you these things, you will not get it. You have to do it. Okay? Here, okay, where you build that. What I am saying is you add a few more keys. You don't have to do it right now. We'll come back to it later, depending on the time. Okay, whatever exercise you have done, we'll add these keys. Okay, when you add these keys, afterwards we are going to delete these keys. When we delete those keys, we are going to apply these rules that are listed here, okay, through some examples. But basically, you have to remember the rules, the 4 rules. You just have to trust me on that. By the way, even I would not remember it. If you give the same exercise to your faculty member, they may probably not get it right the first time. But these are all kind of hard to remember, right? You make some silly mistakes and you go back and refer to it. But the way I make sure my work is correct is, after I remember how in math, when we do that, we always say verify your work. I apply the same principle because I know how the elements of a B tree should be structured, right? So after I finish my work, I'll apply the rules of B tree to see if it follows the rules of. Okay, we'll come back to it. Fair enough? We'll come back to it. We'll have enough time. Because I wanted to cover the pre-order in our traverse time you can spend on this. Yeah. Now when you do some analysis of the B trees, okay, how do we estimate the maximum number of items in the B tree of order M and Ith, right? So when you have root is always m-1, remember? Order M means the first level will be m-1 links. You will m is getting squared, m minus 1 is the constant factor. So if you do the math there, that series, when you do that, basically comes to m raised to h plus 1 minus 1. The case of m equal to 5 and h equal to 2, okay, the number of items that you can store in that is 124. 124. Okay. Okay. We kind of gave the motivation for B trees in the beginning. This is kind of like recapping that one, right? Whenever we want to talk about searching tables held on bullet is very interesting. I want you to pay attention to this one. A B tree of order 101 and height 3 can hold 101 raised to 4 minus 1. Okay? And you can see the power of it, right? That's 100 million items. And then a height of 3 is basically boils down to 3 discretes. Okay? Because the root is in memory. We are assuming the root is in memory. This is not bad compared to an AVL tree with a big depth on the disk. In just 3 discretes, you are able to access the items. Okay? Now, recall, they are all in the slides. You can review them. It's a shorter version of the M order tree. Okay. Other important thing, B trees are always balanced because all the leaves are all at the same level. Okay. Okay. Doing a little bit of comparison of the trees, binary tree can become unbalanced when they are not at the same level, right? And the time complexity changes once they are unbalanced. Okay. And we studied AVL trees where we said that is always of one depth, right? That's what AVL tree is. We didn't talk about heaps yet. Heaps are a mechanism to balance them, but you know, when you use heaps in programming, you typically learn a heap is all indexed, right? It's only as good as the indexes that you create. Whatever the keys that you use to index that, if the key you choose a bad key, then the heap is no good. Later on in our class, we'll study heap and properties, how to choose keys and so on. Okay? Multi-way trees, that's where B trees come into play. And we said that they are used for So, one more exercise. We'll again hold on to it. You will do this also. But let me finish the trees first, okay? Fair enough? So, 2 exercises I'm skipping just for the moment because you just did one good exercise. It shows deletion. Okay. Okay, let me pause here for a second. Questions, comments? So far, so good? Okay. So, when you store all these elements in a tree, right? How do we traverse the tree? Or traverse it is also known as search. There are many ways of traversing a tree. Okay, but the three ways which are predominantly discussed in the literature are pre-order, in-order, and post-order. Okay, so what does pre-order mean? Again, by definition, right? So when you have a tree, You have the root and then you have the left side. Jntuk Moocs said explain the rules of deleting the element in a tree. Okay, I'll come back to deletion after I finish the traversal. Remember I said we'll do an exercise and then we'll know the rules properly, right? Of deletion, right? So we'll actually do the exercise together, applying the rules, and then it will become clear to everyone, just like how you insert it. Now what does pre-order mean? If you look at the tree, right, you have the root node. We all know that. This is the easy way to remember, right? So you have the root node, and then you have the left subtree, right subtree. Three distinct things, right? So you have the root, you have the left subtree, and then you have the right subtree. So this ordering of traversal is related to those three concepts: root, left tree, right subtree. So in the case of pre-order, you visit the root first, meaning you do something, you visit and you do something. It could be display or whatever, right? Print, compare. In the left subtree, you visit the node first, the root. Then you go to its left subtree. Okay? So display the data of the root, go to the left subtree, then go to the right subtree. Now by varying these three bullets is what you get the other types of traversal. So when you go back here, in order, in order what happened, you're saying you traverse the left subtree first. Instead of displaying the root, you first go to the left. Okay, recursively. When I say that, remember there's a recursion because the tree could be n deep, right? Okay. Then you display the data part. Then you traverse the right subtree. Now you get the idea for the post order. Post order, what do? We go to the, instead of going to the left subtree, okay, you go to the left subtree like in before, you then do the right subtree, then you display the data part. So if you go from pre-order to in-order to post-order, all we did was when we would process the root. Okay, in the case of a pre-order, we process the root first. The processing could be anything. This you process the left subtree, then you take care of the root, then you go to the right subtree. In the case first, right subtree next, and then display the root. Okay. Now once again, these are definitions, right? Definitions don't mean anything unless you do an exercise. Okay. So here is an example of a tree, right? So what is the pre-order traversal here? Let's take the help here of faculty members, okay? Pre-order says process the root first, correct? So when I go to the root, what is the root here? Root is 7, correct? So I say process the root first. I put 7. Everyone follows me? By the way, I can screw up. I could make a mistake here. I want faculty members to help me out here. Okay. Okay. After you process the root, then it says go to the left subtree. That's what tree order means, right? By the way, I might remember it now. When I get out of the class, I might forget it also. So, I mean, these are all the things we learn, we forget, and when we if I'm not preparing for the class, I will have to go pick up a book, right? So, okay, so what it says, process the root node, go to the left subtree. Okay, I'm at the left subtree now. Now, what is the algorithm for that? Process the root node, okay, because left subtree is I'm at 1. So it says process the root node, go to the left subtree. Okay, left subtree of 1 is 0. Okay, now I come back. There's nothing else to process beyond 0, right? I come back to the root node and then process the okay, now I want some faculty member to tell me what is the number that comes after 3. Faculty member or even students? Anyone? What comes after 3? 2. Okay, thank you. I'm going, okay. Once they answer it, hold on, okay. 2. Okay, after 2 what comes? Someone else, not Jntuk Kakinada. Pragati also answered 2, Jntuk Kakinada answered 2. Someone else, how about Chaitanya? Chaitanya has been quiet today. What comes after 2? 5. Oh, JNTV answered. Chaitanya answered. Guide. We have guide. How about guide? Guide 1. Guide 2. Oh, Chaitanya answered 6. Okay. Chaitanya, hold on. You answered too many questions now. Guide. How about guide? Pragati, you answered. Okay. I'm asking guide. What comes after 6? Come on. What comes after 6? Guide. Who else is there? Vasavi. Come on, Vasavi. Sixth out 9, Pragati. Okay, Pragati wants to take over the class now. Okay, 9. Order. See? Now, in order. What does the in order say? You get the idea, right? Are you confident now you can do in order instead of doing the root? So what is the very first number in order? Who wants to put it there? Oh my God, somebody gave the full answer. Guide became upset that they didn't get to answer, so they gave the full answer here. So I'm going to put the full answer here. They put it for everyone too. Okay, 0, 1, 2, 3. Oh my God, it's all in sequence. Huh? Wow, I didn't know that. Wow. Was it planned like? I will leave it to your imagination for post order. Okay? Do you find trees fun, guys? To me, I can tell you when I was doing the post order, somebody put it guide. Okay, excellent. I trust whatever you put is correct. Okay, I'm not even bothering to check now. You got the hang of it. Okay. I actually have the answers there. Do they match? Looks like they do. If there is a discrepancy, you can blame it on me. Okay. I can see a post order discrepancy between what guide put and what I have here. Guide, I think, made a small typo there. They put 4 twice. Okay, now this is what I want the students to do. Now faculty members, now rest of the time we are going to spend doing some exercises, okay? Nothing but exercises. Solid time in exercises today. Another 20-25 minutes you have, right? So to do this exercise, why don't we now go back to the delete part, okay? Fair? We'll go back to the delete and do it slowly. Slide number is on the much pen. Let me check. Okay, removal, right? Okay, insert, we are good. Let's do the delete. Do it one more time through the lecture, and then we'll go to that. Okay. So you want to delete, right? What does it say? If the key is already in a leaf node and removing it does not cause that leaf node to have too few keys. So for a tree of order M, how many keys are there? M minus 1, right? That's what we learned from B tree, right? Remember that rule, number 1. Okay. If the key is not in a leaf, that means it is above the leaf. There is a root of that, right? Then or greater than, right? Okay. And then we delete the key and promote the predecessor or successor key to the non-leaf. Okay. 2 rules. Okay, Chaitanya, you're already answering, but I don't want you to answer anymore now because I want students to work on it in groups. The exercises. Okay. But good that you put it there. But I want all the students to work on them in groups after I'm done with deletion of the deletion aspects here. Okay, great. So again, why did the rule come? It will become intuitive to you after you practice. To a leaf node containing less than the minimum number of keys, then we have to look for the siblings immediately adjacent to the leaf in question. Okay, so he's just showing you. Okay, let's look at that. Okay, so this is the 12, 29, 52, and then how many? What is the order 5A tree here? And how many keys are there here? It have 4, right? Less than 12, between 12 and 29. Delete something from this one, and then the deletion he's talking about is something we are deleting here. What are we deleting here? Let me check. I forgot to put the value that we are deleting. Okay. 7 and 9 Trojan for B3. Give me a second. Did I miss a number there? Let me check. Yeah. See the 3, 7 and 9. So you would not lose anything. By deleting it, you would not lose anything. That's what he's saying there. But when you want to delete 56, okay, what you're trying to do is you're trying to delete 56. When you're trying to delete 56, what is the rule that we are following here? Let's look at that one here. Okay, so let's apply rule number 1 here. If the key is already in a leaf node and removing it doesn't cause leaf node to have too few keys, so if you look at 56 here, we applied this rule here, right? If one of them has more than the minimum number of keys, then we can promote one of its keys to the parent and take the parent key into a lacking leaf. Okay, so we are trying to get this, we are trying to delete 52. Actually, we are not deleting 56, we are trying to delete 52. So, okay, there we go. So, we're trying to delete 52 from this. Right? Is 2 keys, does it violate the rule of the B trees here? It does, correct? Because of the disparity here. So, you have to bump up something from the leaf into this. Okay, so that if you go back to the rule here, right? If one or two lead to a leaf node contains less than the minimum number of keys, correct? It has less than the minimum number of keys. When you try to delete 52, it only has 2 keys. Okay. If it has, if one of them has more than the minimum number, then you go through that recursively. So when I do that intuitively here, delete 52, this falls short of the number of keys here. So I have to bring the next highest one from wherever it is up. So if you see here, you got the 56 up. Okay. Now once you bring 56 up, you have to readjust the tree again, right? Again you apply, go back to the rules and then readjust, and then when you readjust these things here, you can have up to 3. So he is going to join these things back together to make it into 1, 2, 3 nodes basically. Earlier we had 4 branches, now we made it to 3 branches. Okay. Type number 4, too few keys in node and its siblings. Okay. So this goes back to the rule number 4 there. If you go back here, for each of these type 1, so you have type 1 here. Okay, type 1 corresponds to this type 1 here. Let me show you. This is key to be deleted. That's very straightforward, right? So in the leaf node, I had a 3 there. Remember, this was the tree, right? If you insert it, you'll actually see that value 3 would have come here before 7, right? Before 7, the value 3 comes. Remember, it's all in sorted order. Remember the B trees, right? 3, 7, 9. So if I have to write it here, I actually had 3 there next to 7. Okay. 3 or 2, whatever is that, right? Corresponds to rule number 1. Okay. Now rule number 2 is what we are looking at again. Rule number 2, what is rule number 2? If the key is not in a leaf, okay, then it is guaranteed to be that its predecessor or successor will be in a leaf, right? That's kind of like proof. It's a simple proof, right? Because that's how the tree is built, less than or equal to or greater than or equal to, right? Rather less than or greater than. Okay. So if it is not in a leaf, what do? We can delete the key and promote the predecessor. You are deleting 52. What does type 2 say? If the key is in a non-leaf node, right? See that one? If the key is not in a leaf, it's either predecessor or successor will be in a leaf. Okay? So we delete the key and promote the predecessor or successor key to the non-leaf node. So go back here. So what is the successor of 52? It's 56, right? In sorted order. So you delete 52 and then you promote 56. Okay, let me pause here for a second. If you have any questions, let me answer. Now, again, I would not be able to remember the rules, but what I would be able to remember is, I have some idea as to how the tree has to be sorted. As long as I know the order that m and m minus 1, if I remember the basic rule order of m, you have m and m minus 1, right? M keys and m minus 1, m nodes and m minus 1 keys, right? Then I would be able to manipulate this. So now if you go back to type 3, so let me go back here, right? Let's go back to the type 4 thing here. Okay. If this is the rule that we have. If neither of them has more than the minimum number of keys, okay, then what do? You combine them, you coalesce them, right? Because you want to make sure the order m and m minus 1 are maintained. That is what rule number 4 is saying in so many words. Okay. So you continue that step recursively till you make sure that the order of m and m minus 1 are maintained. Okay, that is type 4. Now I combine all of them. Would this node where these things are, would it violate the properties? If it is not violating the properties, I will not do anything. Okay. If it violates any property, then I start manipulating the tree. Okay. Now one type of violation would be here. That's what it's showing here. By removing this one here, I'm violating the rule, so I have to bump up the value. No, sorry. I'm removing 52. By violating the rule here, I need to have at least minimum 3 keys here. That is the rule of that tree. By removing one of the keys, I'm violating the rule. So that means I have to replace that Again, I mean, it's kind of hard, and until you do a few examples, you will not appreciate that. So that's the reason why I put the thing for you here. Okay. So now what we'll do is you already built a tree, right? 3, 7, 9, 23. Why don't you do like this? You can add these keys quickly to that. See the tree, and then you simply delete this one and see how the tree would look like. Simple exercise, right? For the next 20 minutes or so, or just go back here, look at the rule whenever you're doing that. There are 4 rules, see which rule applies, and then build the tree accordingly. You do it on a couple of examples, then you'll get a hang of it. Okay. See, there's type 3, type 4. I gave the one-to-one mapping there between the rule and the example for you to help with your exercise. Fair enough? Okay. Put your heads down, ready, set, go. In the remaining time, or you can take some extra time to do it. We are all here to help you. Okay. So five to 10 minutes to add 2, 6, and then 12. Once you add that, then you have to delete those keys 4, 5, 7, 3, and 14. Okay, I see Jntuk Moocs are doing it. What about rest of the guys there? Let me check the video for everyone. Okay. Do you want me to put the rules there? Rules actually are pretty intuitive actually. I'll let you, if you want me to put the rules slide there, let me know, I'll put it. I will bring back one of the fundamental slides here of B trees. That way you know why we don't have to memorize anything here. Remember the rule number 1. Number 5 are absolutely important. And then when it gets tricky, then you start applying rule number 3, because it should have at least m by 2 children. That is integer division, remember? So 5 by 2 is what? 5 by 2 is 2, right? The divisor symbol, because integer division simple. Do some examples, it becomes second nature for you. For your information, I also posted some exercises for you in the community. Please download them and practice those problems. There are 1 or 2 programming problems there. For those of you who want to implement these trees, those exercises would be good. Okay. While you're doing it, if you have any questions or anything, just put it in chat. One of the faculty members or your fellow students from other colleges will be able to answer, if not me. I can see the video of Guide or Jntuk. I can see people are seriously thinking. Don't do it alone, do it in groups. This is a question for faculty members. When you people teach data structures and algorithms class, do you do a lot of in-class exercise or you would not get time to do it? Somebody put an answer there. After deletion of all the keys, 9 is the root, is what you are saying? Okay. Okay, Chaitanya completed. Oh, Chaitanya is on a roll today, along with Jay. Things they are much easier to understand by doing. You can show a video if you're done. 2, 1, 2 to the left. Okay, so there's a 9, 24 and 35 are root. How many of you got 9, 24 and 35 as a root? What I heard was from Chaitanya and from Pakinada, 9, 24. As we are at the end, okay? I want the students to do if you're done with that, take this tree traversal that we have here. By the way, I'm assuming you already copied that one. I moved this one. This was the other exercise that we were supposed to do today, tree traversal. I have this, do a pre-order, in order and post order. Okay. I think I said it right. In order is visit the left, visit the node, visit the right. Okay. Post order is visit the left, visit the right, and then visit the node. Okay. Chaitanya is saying 13 is right for route 12. Okay. Whatever you say, I say it is correct right now when it is 11 o'clock in the night for me. Okay, I can see some papers being passed around. That's good. I'm very proud of that engagement. SVCW did well today. Nobody sent me what your internal exam was, by the way. Why don't one of the faculty members like JNTU or anyone just send me what you gave as internal exam to the students? I'm just curious. You can just email it to me. (4556) it's to the right of Route 35. Okay. There. Remember we had rule 1, 2, 3, 4, right, for deletion. If you go back there, okay, let me ask this complete. That's good. So during removing, if the key is already